Welcome to Conversations from St. Norbert College, a program that invites you into discussions taking place in your community on today's local and global issues. Now, your host for Conversations from St. Norbert College, the Dean and Academic Vice President of the college, Michael Marsden.
Good evening. My name is Michael Marsden, and I'm your host for this edition of Conversations from St. Norbert College. Our special guest this evening is oceanographer Mr. Tim Boyer. Mr. Boyer received his undergraduate degree from St. Norbert College and his graduate degree in oceanography from Old Dominion University in Norfolk, Virginia. Mr. Boyer conducts research on ocean heat changes at the National Oceanic and Atmospheric Administration's Ocean Climate Laboratory in Silver Spring, Maryland. He's part of a large team of scientists who contribute to the UN's Intergovernmental Panel on Climate Change, the IPCC, and their report. This is the same IPCC which, along with former Vice President Al Gore, were honored in 2007 with the Nobel Peace Prize for creating an ever-broadening, informed consensus regarding the connections between human activities and global warming. Mr. Boyer has given presentations on global warming in countries throughout the world. Our topic this evening is climate change. Tim, welcome to our program. We're really pleased to have you with us. Could you just quickly explain to the audience, what exactly you do as an oceanographer, for NOAA?
Yes, well, the Ocean Climate Laboratory is part of the National Oceanographic Data Center. And what we try to do is gather together as much historical temperature and salinity profile data, and profile is a measurement from the sea surface to a continuous measurement from the surface to as deep a depth as you can go. To gather together as much of that data as we can over historical time periods to try to get a picture how the temperature and salinity have changed over time, and then to calculate changes in the ocean heat content and freshwater content.
How far back do your records go?
Well, we have records back to 1773. We have them from Captain Cook's voyage, where he theorized that the water below the surface in the Southern Ocean, the ocean around Antarctica, was cooler than at the surface, so he put bottles down to test that. But oceanography really got going as a science about 1900 in Norway, in the Baltic states, and spread from there. But really, until the post-World War II period, we don't have very much data. So we can't really look back much further than 1955.
Really? Okay. Now, I know you're working with some Russian scientists, though, to get some additional historical data, correct?
Yes, the Russians have some amazing time series that go back more than 100 years.
Why were they collecting it in particular, do you think?
Well, I mean, they're very interested, especially in the Arctic, changes over time. And their seaports, the Russians don't have that many seaports, especially in warm waters. So they had to be interested in understanding the changes in the Arctic. But from a scientific perspective as well, they're interested in changes up there. And in the Soviet period, they really ramped up their oceanography program and did a huge amount of work globally, kind of as part of the Cold War competition in the sciences, but also for its valuable information militarily and for fisheries.
Mm-hmm. Interesting. Now, how do you move? Tell me the journey that you encountered here, moving from an undergraduate degree in physics and math at St. Norbert College to now your work as an oceanographer. What's that journey like?
Well, I as you said, I graduated with degrees in physics and math here, and I really love to be outdoors. I love the idea of working towards a better understanding of the environment, contributing somehow to environmental understanding. Oceanography, physical oceanography, lets me use those math and physics skills and also, at least in the ideal case, be outdoors on cruise.
Do both. That's very good. Now, you're part of these team of scientists who, as I said in the introduction, you've contributed to the UN's Intergovernmental Panel on Climate Change, or the IPCC report, which in turn, of course, had other impacts. But what exactly did your particular group, what exactly did they contribute to that report?
Well, we contributed in two aspects. The main one is probably in the ocean heat content. We published a paper in year 2000 called Warming of the World Oceans, and it shows these time series that we were able to get since 1955 a fairly steady warming of the ocean globally since that time, which translates to a sea level rise of about 20 millimeters. And the sea level rise is related to ocean heat content because as water warms, it expands.
Sure.
So that time series was our main contribution to the IPCC. But we also we have much less salinity data, and salinity is related to changes in fresh water. And that fresh water the major sources are from melting glaciers on Antarctica
Sure.
and Greenland. So we did some, not quite a time series, but some zonal averages, latitudinal averages of salinity to show how that's been changing since 1950.
And when you talk about the change in the water temperature, what level of change are we talking about specifically over that time frame?
Well, in actual temperature, I mean, I honestly get asked that a lot, and I never have a good answer because we work, the ocean heat content, the units that we use are joules,
okay.
A unit of energy. And we do translate that when we talk about sea level rise into millimeters, and that's probably the easiest to understand, and that's
okay.
why I talk about it comes to, since 1955, about 0.4 millimeters rise in global sea level per year.
That's how you get to the 20.
That's how we get to the 20.
Mm-hmm. Interesting. And that makes sense. Now, the IPCC and then former Vice President Gore together received the Nobel Prize in 2007 for their work. That certainly must have been a very proud moment for all of you who contributed to that. And did you celebrate?
I don't think really. I mean, I heard it on National Public Radio the morning that it was, or the day after it was awarded, and it was more a sense of disbelief than anything. Went to work.
Why disbelief?
Well, it's a Nobel Peace Prize, and
mm-hmm.
it honestly didn't, I mean, I thought it through since then, but it didn't seem really appropriate to be given to Al Gore and a group of scientists working on climate change.
Yeah. But now, in retrospect, it was quite appropriate.
Well, when I thought about it, and actually this talk that I'll give for the Peace and Justice Center made me think about it more deeply. I mean, one of the major causes of war is a scarcity of resource, or disproportionate resources between different countries. And so what the IPCC did, I mean, my part was looking at the basis for proof, if you will, for climate change. But there were two other parts, and one was what are the effects on human populations, and then the third part is how can we mitigate climate change. Mm-hmm. So basically what the IPCC has is a blueprint for how to avoid conflict through mitigating climate change. Mm-hmm. So in that respect, it is a recipe for peace.
Interesting. Yeah, very interesting. And very true. Now, it's been said many times in a lot of venues that any change in the ocean's heat content has major consequences, for society. What do you think some of those most important changes are?
Well, the most important, I mean, the first one is that the ocean is a heat sink, meaning it absorbs a lot of heat. It takes that heat solar radiation that's coming in, and it stores it deep in the ocean. So it absorbs a huge amount of the heat that would otherwise be in the atmosphere and causing the atmosphere to warm. So it's a storage device. I mean, at some point, that heat's going to come back to the surface and be released. Right. But at this point, it's kind of, in itself, mitigating the effects of the greenhouse warming. It also has effects, obviously, not obviously, but as we mentioned before, on sea level, which is extremely important for a lot of countries around the world,
of course,
including the United States. It's also important for hurricane intensity and generation, because hurricanes get their heat not just from the surface of the ocean, but below the surface. And I always use the example of Hurricane Katrina. It surprised hurricane prediction by hitting land as a Category 5 instead of a less intense hurricane. And the reason for that is that it gained a very large amount of energy from subsurface a warm pool in the Gulf of Mexico. So heat content has a lot of implications for different aspects of climate.
I did not know that. That's interesting. There continues to be a lot of resistance, and I would like you to comment on this, in accepting climate change issues. And particularly, for example, just to borrow the phrase that Vice President Gore used, an inconvenient truth. Why is there this resistance when all the scientific evidence is so strong?
Well, I think the scientific evidence is strong, but you can always poke holes in it, in some respect, because we don't have that long of time series. I mean, ocean heat only goes back 55 years. The satellite era only from the late 70s. So there's a lot of natural variation in long cycles, 50 years, 100 years, things we know nothing about yet. And these variations are going on along with any change that is induced by man-made CO2 and so on. So you can always look and say, well, look, last winter was actually colder than normal, where you say the Earth is warming up. So these cycles are mixed in there, and we really don't understand that much about the climate.
But you yourself feel there is a problem here that we need to address.
I do think there's a problem that we need to address. I think we're never going to prove it conclusively that the man-made CO2s and other gases are causing climate change. But there is enough evidence compiled by the IPCC and in a lot of other areas that says we really need to do something, even if we're not 100% sure. And I use the example, hurricane prediction is not an exact science.
Not hardly, no.
But if someone told me there's a hurricane that might hit your house, I'm going to do something. I'm at least going to board up the windows.
Sure.
So even if we can never be sure, we should still try to be doing something.
It makes sense to take some precautions. Agreed. I just want to remind our viewers that you're watching Conversations from St. Norbert College, and our special guest this evening is oceanographer Mr. Tim Boyer. And our topic this evening is climate change. Now, you've done some very specific research on the effects of adding a lot of fresh water to the oceans. I mean, that's one of your areas. In fact, I think you gave a presentation, according to my notes, last year in Switzerland on this topic, particularly your work in the Bay of Bengal and the Arabian Sea. Now, what did you find in that research that you then reported on?
Well, what we're finding in the Bay of Bengal, and I've been working with some Indian colleagues on this topic, is the Bay of Bengal is an area that's, I should say the land around it is very susceptible to changes in sea level. Bangladesh, for instance, there's always stories about flooding there and so on. So it's a big topic there. But the thing is that what we've actually been seeing, even though sea surface temperatures have been going up in the Indian Ocean quite rapidly, is that sea level in the Bay of Bengal has been staying either level, constant, thank you, not level, constant, or been going down a little bit in some areas. And this is really a mystery. Why is this happening?
Yeah, why is it?
Well, we have a 20-year time series in the Bay of Bengal. Actually, the Indians do, and I'm working with them on this. And I don't have an answer for you right now. But what we think is that despite the warming at the surface, there is cooler water coming in, cooler than normal water coming in from outside the Bay of Bengal. So any expansion due to that surface warming is being counteracted by the cooling water that's deeper down. But this is just speculation right now. We really need to look into this further.
And where do you think that water is coming from?
Well, that's a good question. I can't answer that.
But it's an influx of fresh water, though. Correct?
It's not necessarily an influx of fresh water. I'm talking about fresh water changes in one aspect, but it's also this is cooler water, not necessarily fresh.
Okay.
The fresh water, there's a lot of freshwater input there from the Brahmaputra and Ganges River, which flow, have a huge outflow in that area. So that's what makes it so complex, is they're adding so much fresh water from these rivers, and then the monsoons coming over and very variable and dropping a lot of fresh water. Mm-hmm. So we've got to bring all these things together that are affecting sea level there and try to get an understanding of why it's not going up. And we're just at the beginnings of this. So I really don't have a lot of answers in that area.
Well, understandably, but it is fascinating to find that change. I mean, the change itself is interesting, and it's, as you said, it's dramatic. It's not slow.
Yes, and that's the thing where we see that nature is always surprising us. We expect one thing, and at least regionally, a lot of different things are going on that we don't understand yet.
Now, in 2004, you traveled to Antarctica to measure ocean issues, as well as to, I think you did some work on krill, or shrimp-like creatures in the ocean, trying to determine their populations. Now, how was all that research related, and what was the result of that?
Well, what we were trying to do down there, is called, the project was the Southern Ocean Globex, and on the western side of the Antarctic Peninsula is can't say perfect, but a wonderful breeding ground for krill. They range from about 1 inch to 5 inch animals, shrimp-like animals that are main food for whales and a lot of other animals. Nice. So this is a very good breeding ground for it. And then once they breed it on the West Antarctic Peninsula, they catch the Antarctic circumpolar current and are whisked out into the middle of the southern Atlantic, where they are the food for the fishing grounds there. And so we were trying to understand the physical, chemical, and biological factors that made it such a good breeding ground, and if that was changing and so on. And it was a 10-year project. I was only out there 1 year. And what they had theorized, I think it was the 4th year that they had been out there, and what they had theorized from the year before as for inflow of nutrients, we didn't see. We saw something completely different the year I was there.
Interesting.
So,
what did you find? That 1 year at least.
Well, we found, previously they found that the colder temperature waters were high in the nutrients. So they were theorizing that this water coming around and into this area was what's feeding these krill. But we saw water coming from a different area, warmer water, that did not have this nutrient content. So it may have been an anomalous year, or it may have been more than normal.
And that's why you need the longitudinal, data.
Yes, and that's why you need the longer-term program.
It is surprising there wasn't more long-term data collected on some of these issues, given their importance. But I suppose it's something scientists have just begun to really take seriously.
Yeah, well, it's very hard to do work on
it is.
In the Southern Ocean.
Yeah.
So.
Now, I said earlier that you're working with some Russian colleagues to get some longitudinal data that's very helpful, particularly in the Arctic. That subsequent to the fall of the Soviet Union, they began to open up their records more to, I guess, non-Russian scientists. How do you find working with them? How do you find that experience?
I enjoy very much working with the Russians. We put out a series of atlases. Their institutes, after the collapse of the Soviet Union, had a huge amount of data that they built up and a huge amount of expertise as well. Mm-hmm. But a lot of the funding for these type of sciences dried up to some extent, although it's coming back now. So this expertise and these data, we would work with them, sometimes through funding, but usually directly, to make atlases of different areas, the White Sea, the Bering Sea, the Northern Pacific Seas, the Sea of Okhotsk, and the Barents Sea, and then use the long time series they have, along with the data we gather from other sources, to look at the changes in those areas. And these areas, the Arctic, the changes in there are much larger, in most extent, than for the rest of the world. The changes are hitting the Arctic, at least in this time period.
Interesting.
More than most of the rest of the globe.
More dramatically.
More dramatically, thank you.
More dramatically. Oh, very interesting. What kind of future research are you and your colleagues planning at NOAA? At least that you can talk about. Maybe there's some, it's classified, but...
Well, I mean, we work for the government. There's nothing classified. Everything we have is completely open and public. We're continuing our work on heat content. It's kind of been a revolution in heat content research lately. Since about 2006, there's been the Argo Profiling Float program, and this seeds the ocean with automatic sensors, with autonomous sensors, which drift for 10 days at 1,500 meters. Then they drop to 2,000 meters and take a temperature and salinity profile to the surface.
Goodness, really?
And then they send that information to a satellite. So basically, before we had to go out on a cruise to wherever we wanted to go and put down instruments.
Soundings, yeah.
It was very tough to do. Now we have it's an amazing project. The ocean is fully seeded, ice-free areas, and so we're getting as much information in a month as we would get in maybe a 10-year period before, and from places we never had data. So going forward, we have a huge amount of information, and we can start to see seasonal cycles in northern, southern hemisphere, all kinds of things that we weren't able to look at. And now the freshwater part, salinity is a very tough measurement. You need to have very accurate instruments. Now the Argo is giving us that as well. So
interesting.
It's a huge opening field, and there are a lot of people starting to do this work, and we're one of the groups doing this.
How do you pick a project? I mean, what process is used in your organization to choose this project, that project, et cetera? I mean, how free are you to choose what you want to work on next?
I have a lot of freedom. I mean, we have some basic tasks which we're funded for, and one of them is to put out monthly updates of the ocean heat content. Mm-hmm. And we always have to be on the lookout for historical data that will augment what we already have in the past and maybe even move our time series back. But, for instance, my collaboration with the Indians was just kind of organic through talking to them at meetings.
I see.
So we have a lot of freedom to do these research as long as, of course, it's related to our main topic of this type of ocean climate change. But it is exciting to work where I do because we do have this large amount of freedom.
Can I go back to your hurricane issue that you mentioned before? Is it possible that you in the future might be able to predict the intensity of a hurricane by charting the heat content of the ocean waters that passes over? Is that a possibility?
I can't pretend to understand hurricanes that well. I understand the heat content part, but it's a very complex. I mean, you need minimum sea surface temperature of 28.6 degrees, I think it is, but there's a lot of other factors involved there. Okay. And I only know, once you get above the sea surface, I know nothing. Well, I shouldn't say nothing, but I know very little. So I'm really not qualified to speak to that. I probably know the same as you, what I see.
But it'd be interesting to know if hurricanes could build strength. I mean, they build strength in different kinds of ways, I'm sure. But if that's one of the predictable ways, that would be interesting to know.
Well, and I have seen at the last meeting I was at in Portland, the Ocean Science meeting, they have started to incorporate observations of ocean heat content into the hurricane models, cyclone models, to make it global.
Right.
And they have been able to different extents for different oceans, enhance the skill, they call it, the ability of these models to predict hurricanes. So I think it's very promising for the future, but I really shouldn't speak too much on hurricanes.
No, but it would be very interesting to know if there's a better modeling device out there, because I mean, hurricanes are so destructive and
right, yes,
so threatening. If you came across a group of aspiring oceanographers, young students who thought they might have a career in it, what kind of advice would you give them?
Well, I've spoken with two classes over the last 2 days, and
here at St. Norbert.
Here at St. Norbert's, yes. And the advice I gave them from the perspective of St. Norbert's, that number one, you need a good grounding in math for any of the disciplines in oceanography, either biological, chemical, physical, or geological. But beyond that, I think the liberal arts education here at St. Norbert is actually a very important aspect. It I think helps a lot. As you've seen from what we've been talking about, nature is really full of surprises. And you might think one thing, and the next piece of data you get says something completely different. And kind of this liberal arts education has really kind of opened the mind to being able to look at things in new ways, not having kind of a tunnel vision. So I actually think that's very important. And then there's definitely a need for computer skills. And when I talk about computer skills, I'm talking about programming, either shell programming or even a language. Because oceanographic data, and I'm sure a lot of other geophysical data, don't lend themselves to commercial type databases. To really be able to analyze these things, you have to be able to program it up very quickly and get exactly the type of questions you want through the computer. So it's very important to have some type of skill in that area as well.
Now, how often, when you go off on one of these expeditions, how long are you gone from home?
Well, they vary. The Antarctic cruise was 7 weeks, and that was actually my last cruise that I've been on, because it's kind of tough. I have a young family. It was kind of tough on them. I'd like to go back now that they're older, but you're talking at least a 3-week investment, but yes, sure. But up to, I mean, some of these longer cruises across the Pacific can be 2.5, 3 months. Are
you collecting data all along the way as well?
Well, as much as we can. For instance, in Antarctica, you pass through the Straits of Magellan, and you're in Argentinian waters. Yes. And they do not allow
you to come in.
Any instrumentation to be dropped there. So you have to wait till you're out of their economic zone. But as soon as you are in the Drake Passage and then in Antarctica, yes, we're taking measurements constantly.
But wouldn't they benefit from having that information from you? Wouldn't they? They may have reasons for not allowing the ships in there, but I mean, good reasons. But they would benefit from that data.
They would, yes. But it's also, especially in coastal areas, fisheries and military applications of physical oceanographic data make countries very wary of sharing that type of data.
For security, I'm sure. And we talked earlier about the whole issue of global warming and how it's taking a while for people to accept the truth of it all. Are there things the average citizen can do, though, to make a difference?
Yes, there always are.
Such as?
I mean, these are the usual things. I don't have anything revolutionary, but use efficient cars, or use them as little as possible. recycle, keep the heat down in your house in the winter, or the air conditioning down in summer. I mean, these are the usual things, but they do add up, and it is important for individuals to try to do this. The example that's out there is the ozone layer. The ozone was being depleted due to chlorofluorocarbons, right. And most of these were from underarm deodorant sprays and aerosols, right. So individuals, I mean, once the education was out there and individuals saw, well, I can make a difference just by using a roll-on, they were able to, and the ozone hole is on its way to being repaired, well, more or less repaired.
At least not further damaged.
Yeah, so individuals can make a big difference by doing pretty small, relatively small things. Of course, it's a sacrifice.
What's on the horizon for you? Let's say, project yourself out 10 years and look backwards. What kinds of projects would you like to have accomplished in 10 years from now?
In 10 years from now? Well, that's a good question. I haven't
given that much thought to it.
Given that much thought. I would like to, the IPCC next assessment is getting underway. Mm-hmm. So I would like to be part of that, and I'd like for that assessment to, hopefully we're done with the basics. We've proven, not proven beyond a shadow of a doubt, but we've shown that there's a lot of evidence that shows that greenhouse gases are causing climate change. So that we would actually be able to go beyond a wish list of a blueprint for mitigation to actually implement some of these things. Mm-hmm. Now that's more on the citizen side than the science side. The boring answer is I'd like to continue with this research and get a better understanding of changes in the heat content, changes in the fresh water. We still need a long way to go in that. Just kind of refine what we've already done.
When we talk about the IPCC report, how many scientists work on that report?
Well, I added that up because I was curious about that too. And I'm just talking about Working Group 1, the part that I was in. But I counted, and there were, this number's not going to be exact, I don't remember, but about 700 scientists.
Okay.
Beyond that, there were 641 reviewers. And these were not just scientists, but they were from government agencies around the world and also from business.
Reviewing the data that the 700 collected.
Yes. So it's very rigorous.
I guess so.
And it's a large compilation. And the summation report does go to all these governments for approval. So it's a very rigorous process the whole way through. And
again, it's a UN-sponsored.
It is UN-sponsored, yes.
Good. Well, I certainly want to thank our special guest, Mr. Tim Boyer, for sharing his expertise with us this evening. Please join us for future programs as we continue our exploration of the world of ideas. Until then, I'm Michael Marsden for Conversations from St. Norbert College.